Question number 24 is electrostatics. It's a second occurrence. And now it's a straightforward question of common potential sharing and the heat energy which is produced. C1 is there 5 microfarad. The potential is 220. And it is connected to another 2.5 microfarad. And we need to calculate the energy change, or what we call as the heat. So that can be calculated by half. Specifically, this is the standard formula, C1 C2 by C1 plus C2, V1 minus V2 whole square, where V1 and V2 are the initial potential difference of the capacitor involved. Now V2 is of course 0 because that was initially uncharged. So when you calculate that, you would be getting this value to be very close to 0.04 joule. So in that case, the value of X comes out to be 4. That's for question number 24. Let's go for the final question, the 25th question. And the 25th question is from electromagnetic induction. Now what does it say? There is a circular coil, the radius has been given, it is kept in a magnetic field with its plane perpendicular to the field initially. So let's try to draw with a little bit of diagram, shall we? Okay, and here is that axis as per the question if you go through, and it rotates in this way. The magnetic field is perpendicular to the plane initially, so this is how we can represent. Now let's see, the radius r has been given. Let me pick up the variables first. The magnetic field is given, and we need to calculate omega. For that, a little bit of exercise has to be done. It says that it makes half of the rotation in 0.2 seconds. So quite obviously omega, that can be calculated as pi divided by 0.2. That means essentially omega is also known. We need to calculate the maximum value of EMF induced in microvolt. In other words, the amplitude of the EMF. Isn't the case of an AC generator? Yes, it is, isn't it? So how do we do? We start in this way. Phi at any instant is B area. Let me write it as A itself. Later on you can plug as pi r square and cos of omega t. Alright, at any given instant. The EMF minus d phi by dt will give me BA omega sine omega t. And this is what essentially we need to find, the amplitude of the EMF. You do that, you would be getting the value as 15 microvolt. So the answer would be 15 for question number 25. And this is all from my side, the solution session of question paper that had been asked on 2nd September morning shift. I will meet you in the next solution shift. See you there.